Find the y-intercept, if any, x-intercepts, if any, vertical asymptotes, if any, including the asymptotic behavior on each side, and holes, if any, for f of x equals x squared minus 10x divided by x squared minus 5x. First thing to find is the y-intercept, where the function crosses the y-axis, defined by x equals 0. The corresponding y-coordinate can be found by plugging the x-coordinate 0 into the function, so y will be f of 0, which will be 0 squared minus 10 times 0 divided by 0 squared minus 5 times 0. 0 squared is 0, minus 10 times 0 is 0, divided by 0 squared is 0, minus 5 times 0 is 0. 0 minus 0 is 0 over 0. This is not a limit, so this is not an indeterminate form. That 0 in the denominator actually is a 0, which is not allowed, and therefore there are none. The remaining parts are found by taking the function f of x, which is x squared minus 10x divided by x squared minus 5x, and fully factoring. In the numerator, there's a common factor of x, leaving x minus 10. In the denominator, there's a factor also of x, leaving x minus 5. And canceling out any common factors, the x's will cancel, leaving x minus 10 divided by x minus 5. The x-intercepts, where the function crosses the x-axis, corresponding to y equals 0, are found by taking the remaining numerator after everything's been canceled and setting it equal to 0. Solving for x gives the corresponding x-coordinate. The x-coordinate's a 10, and the corresponding y-coordinate is a 0, y equals 0. There's the x-intercept. The vertical asymptotes are found by taking the factored and canceled version of the function and setting the denominator equal to 0. Solving for x, there will be the vertical asymptote. We can now analyze the asymptotic behavior on each side by taking the left-sided limit, indicated by the negative superscript on the 5, of the factored version, and the right side limit indicated by the positive superscript on the 5, again in the factored version. Let's start with the left-sided limit. The left side of 5 means less positive than 5, like 4.99. If that's plugged into the x that's making 0 in the denominator, which is x minus 5 factor down here, 4.99 minus 5 is a negative number. It will approach to 0 as x approaches 5, but it will stay negative. We can replace x minus 5 with a negative 0. 5 can now be plugged in for all remaining x's, which will be the x in the numerator here. 5 minus 10 is negative 5 divided by negative 0. Negative over negative is positive. Non-zero over 0 is an infinity. The right-sided limit will work out in a similar fashion, but the right side of 5 is more positive than 5, like 5.01. If plugged in for the x in the factor that's making 0 in the denominator, 5.01 minus 5 will be a positive number. It will approach to 0, so x minus 5 can be replaced with a positive 0. 5 can now be plugged in for all remaining x's. 5 minus 10 is a negative 5 divided by a positive 0. Negative over positive is negative. Non-zero over 0 is an infinity. There's the asymptotic behavior on each side of the x equals 5 vertical asymptote. Last thing to determine are any holes in the graph. Holes occur when, in factoring, a factor fully cancels from the denominator, so it's not left over in the denominator. And that happened with the x. we take the factor that fully canceled and set it equal to 0, and there's the x-coordinate of the whole. The corresponding y-coordinate can be found by plugging that in to the factored version, which will give 0 minus 10 divided by 0 minus 5. 0 minus 10 is negative 10 over 0 minus 5 is negative 5. Negative 10 divided by negative 5 is a positive 2. The x-coordinate was 0. The corresponding y-coordinate was a 2. And a hole will be found on the graph at the point 0, 2.